So story problems some story problems fit this y equals mx plus b, the slope-intercept form, really nicely. In which case, this equation rocks. Y equals mx plus b rocks. This new section, section 8, is the last type of line equation we're going to get in this chapter. And it's a line equation that at first glance looks really awful, but there's other types of story problems, there's other situations where this equation is just insanely helpful. So it's definitely worth learning. So 5-8 is going to be point slope form. Sometimes it's called the point slope theorem for a line because they've derived it. You derive theorems, but that doesn't really matter a whole lot. So I wouldn't write this down, but just want to make the point. So yesterday we did y equals mx plus b, and we called this slope-intercept because m is the slope and b is the y-intercept. Agreed? So that was yesterday's. Today we're doing a different one that's called point slope. So this new equation is going to work when you know one point that the line goes through and you can figure out the slope of the line. And it fits really nice with some story problems. So I'm going to start out just with Roman numeral 1, and I'll say the equation. And like I said, it looks bad, but once you learn to work with it, it's really not. But we have y minus y1 equals m parentheses x minus x1 parentheses. A bundle of joy. That would be a good way to describe it, perhaps. But we have this here. Now, we said it's the point slope form, so we know a point, we know the slope. The slope is just going to be what letter in there? Yep, so m is going to be the slope. The point, anyone want to take a guess at what the point's going to be? Well, y1 and x1. So the x value is going to be the x1, and the y value is going to be the y1. Because typically equations still have like an x and y or two different variables in it, right? So this x here and this y here, those are just normal x's and y's. Those are going to be the variables. So when we get done writing our equation, that x and that y should still be just x and y. So what we're going to do is we're going to take and put the x value for our point in x1 and the y value for our point in y1. Yes? So let's keep going. My Roman numeral 2 is going to be the writing equations. So writing equations. Yeah, the notes are kind of long today because I'm trying to kind of cover like the different situations you're going to see, try to hit all the bases. So example 1, you could have something like write an equation for a line through the point 3, 2. So write an equation for a line through parenthesis 3, comma 2, parenthesis, with a slope of 4. I'm going to ask you to know this equation from memory when we get to the test. So please make it a whole lot easier to study for the test and just get in that habit of, at least for the first day or two, write the equation out before you do the problems. If you do that, it makes the problem way easier, and you'll know it from memory. Give yourself a day or two of doing this. All right. Maybe let's do the slope. My slope of 4. Where do I put my 4? M. So I'm going to put a 4 down there. And I'm going to kind of copy in a little bit of the other stuff at least. So I put in my equals, my parentheses. The 3, where does the 3 go? X1. So I have a 3 over here, and it's x minus x1, so it's going to be an x minus a 3. Are you agreed? What do you notice? We had a positive 3. In the equation, it becomes a minus 3. It switches. If we look at the y1, so now we have y minus y1, so y1 is going to be our 2 value there. So y minus 2. So the same thing with the 2. That's the most common thing I found that mess people up on these, is when they look at the equation, they see a minus 3, which my brain then says negative 3, but that's really a positive 3. You have a y minus 2, I think negative 2, but it's really a positive 2. And if you're a math hater, you could just tell yourself, the equation's stupid. It's always the opposite of what it says in the equation. But anyways, make sure you get it right, though, because that's going to be something that comes up and gets some of you. All right, example 2. Example 2. Maybe, let's do this. Find, example 2. Write an equation through, for a line through -2, 7 with m equals -8. Sorry, trying to save a little bit of time in how I write it. So write an equation for a line through -2, 7 with a slope of -8. Feel free to jump ahead and try to beat me to the answer. Maybe write y minus y1 equals m, x minus x1. And I'll give you a second to try to throw the numbers in there today. All right, moving on. All right, so I'm going to start putting the numbers in. And so my slope is going to be a -8. Y minus what? Y minus 7 or y plus 7? Y minus 7. Over in the parentheses, we should have a... Ooh. You could say x minus a -2, but the simplified version would be to say plus. So if you do x minus a negative, I take off a quarter point, and you're like, but because it's a -2. And again, notice when we have a -2 in our point, it shows up as a +2 in the equation. So the signs are always switched in the equation from what they are in real life. All right. No. When you do this, this is a totally legitimate answer. So if you write an equation for a line, you just put in those 3 things, you smile, and you say, I'm done. And it's nice. It's nice. Roman numeral 3. Graphing. I'm going to say graphing / info out, which seems kind of dumb. But basically, look at the equation and be able to pull numbers out. Here's an equation. What's the slope? What's the point? And kind of go from there. So my third example now, example 3. I'm going to say is graph y plus 1 equals 2 and then an x minus 3. So graph y plus 1 equals 2, parentheses, x minus 3, parentheses. I'll see if I can might end up being on top of myself here, but what's the point going to be?
It's going to be 3,
Woo, okay. My x value comes from there in the parentheses, right? So if I have a x minus 3, my x value has to be, it's always just 3. It says minus 3, so it's going to be a positive. It's always switched. The equation here says y plus 1. It's going to be a -1. Perhaps what I should have done is this. I think I lost a lot of you. Some of it has just got crazy. But if you get to one like this and you're confused, this is what I really should have done first. If you take and have an equation in this form and you're looking at it, you're not sure what's what, write the general equation right up above it. Now you can say, well, if I look over here, I have x and then minus my x1. x1 has to be 3, right? Positive 3. Here I have my y's. Now I have a minus and a plus, which becomes a problem. But I could say that plus is really the same as y minus a negative. And now I have my minuses lining up, and my y1 has to be a -1. Just see how you can kind of line things up and pull them out of the equation that way? So that might be a way to start until you get pretty good at it. And then from there you'll find where you can start doing them in your head. All right, the slope then is going to be 2. So if you want to graph this, To graph it, we know the point 3, negative 1. So yesterday in the slope-intercept, we said put a dot on the y-intercept, use the slope to find more points. We do the same thing, but instead of putting a point at the y-intercept, we put a point right there. So I have my x value is 3, so over 3, down 1. So that's my point 3, negative 1. Now my slope is rise over run, 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. You could do the same as if you go down 2, left 1. So down 2, left 1. Pull it together, my friends.
They're doing it wrong. It's like a perfect line.
I try. I try. So example 4. Find the point and slope in, we'll say y plus 7 equals 8, x plus 5. And you could jump right to the answer if you want to. I'm going to go through and do my y minus y1 equals m, x minus x1, try to line it up. So think about it a second, try to figure it out on your own, and then look up at the screen and see if you get the right answer.
So for slopes, do you have to switch it or not? Or is it just a variable?
Because the question was, do you have to switch it with a slope? Because slope is just m, it's not a minus m, it's the exact same. So I gave you both of them as being the plus 5 and plus 7, which you remember has to be looked at as though that's the same as the minus and negative. So that's how we get the negative 5 for the x value, and the negative 7 is the same type of thing for the y. Let's keep going, though. It'll make things easier. All right, Roman numeral 4, equation from story problems. So equation, so you're trying to find an equation from a story problem or 2 points. The whole key to doing this is we're trying to put it in this point-slope form. So to do that, you need to find a point. Then you can put that in for x1 and y1 and find the slope. Then you put that in for m, and you're done. So my first example, which is the 5th example so far, so example 5 is, to say you're trying to find an equation through the point 2, 9 and 5, negative 3. So you're trying to find an equation through 2, 9 and 5, negative 3. Well, I'm just going to kind of start over here and say we have y minus y1 equals m, x minus x1. Does it matter which point we put in the equation? No, because both points are on the line, so pick one. Doesn't matter. I'd probably go with the one on the left just because I usually avoid negatives if I can. So the left side of my equation becomes y plus 9 or y minus 9? Minus 9. Yep, because we put in a positive 9, y minus the positive 9. Inside the parentheses, then we have a x plus 2 or x minus 2?
Minus 2.
Yep, because it's x minus the positive x value. So the only thing we need to fill in now is the slope, because all of our equations typically have like an x and a y still. So for the slope, then we could say, well, it's going to be my y2 minus y1 over x2 minus x1. That's our slope equation. If you want to, you could go through and label your points x1, y1, x2, y2. And we'd have m equals negative 3 minus 9 over 5 minus 2. So then we have a negative 12 over 3. So slope becomes negative 4. So we put a negative 4 in there, and we're done. Does that seem to make sense? And if you'd done the same thing with the other point, just instead of being y minus 9, you'd have a y plus 3. And it would equal negative 4, parenthesis, x minus 5. So you just would change the x1 and y1. And I wouldn't say one is really any easier than the other. Jump to the last thing then, I think. Unless you have any questions. Example 6. Example 6. Picked on my wife as I was sitting at home trying to figure out what in the world to do for story problems. Michelle had 85 books at age 10. If you marry an English teacher, you don't want to move very often. I'll just say that. She gets, I made up a number, I don't know if this is true or not, but 21 new books each year.
Is this true?
I kind of made up the 21, but I wouldn't be shocked if that was the number. Write an equation. Showing her number of books. And I'm going to call that the y, because the number of books depend on the number of years, right?
Yep.
So the number of books is going to be the d, is going to be the y, in x years. Actually, I guess I should leave it there. We did get married and moved into a third-floor apartment, 32 stairs. Lived there for 1 year, then moved into our house. Another 32 stairs. 32 stairs carrying books. That's a lot of stairs. Okay. So we need a slope and we need a point. Maybe do slope. Slope's easier. What goes in for m? X was the number of years, 21. Because every year, do you agree we're adding 21 every year? So if you think of the graph, every time you go over 1 on the graph, we're going up 21. So the m is going to be 21. And if you wanted to, you could even still put in like just your x and your y, just your part right there. All we need now is the point. Well, we have two other numbers, 85 and 10. Is it 85 comma 10 or 10 comma 85? Because
85 depends on time.
Yep, that we had at age 10 was the number of years, 85 is the number of books, but the 85 depends on the 10. We said that the number of books depends on how many years have gone by. So it'd be y plus 81, y minus 85, I didn't have the wrong number. Y minus 85 and x minus 10. I don't remember if our book asked you to do this, so I'm going to skip my last example just in interest of time. Oh no, actually that is my last example. Example 7. Oh no, it's not. How many books?
30 seconds tops.
How many books when she gets married? We'll just say when she is 28. Can you stay with, where do you put the 28?
That goes.
We're trying to say how many books does she have when she's 28? 28 goes in for x. So what we do is we take the 28, because 28 is the year, we put it in right there. So you end up with y minus 85 equals 21, 28 minus 10. And now we could go through and solve that problem. We could say, well, this is 18 times 21. So their order of operations, we had to take care of what was in the parentheses first to give us the 18. Then 21 times 18 is 378. Then we have our y minus 85 equals that. And then last step is to get y by itself. So we do the inverse to both sides. So we add 85. And that gives us an answer of y being 463. So in this story problem here, Michelle would have had 463 books when she got married at 28 years of age.